Alright, this is a simple calorimetry problem, except it's a two-step. So what we have is a simple Q, which is mass, times specific heat, times delta T. And we have two items placed in contact, which in this case is lead and water. So we have a negative placed on one of them. Again, it doesn't matter which one. So I'm going to set up and I'm going to try kind of here for the center. So Q of lead is going to be equal to minus Q of water. So trying to keep my equal sign so it's easier to follow, I'm going to start way over here. So 2.85 grams of lead times the specific heat of lead, which is 0.128 joules per gram per degree C. Now, because we're placing these in contact, they will have the same T final for both. We're looking for, and that's this thermal equilibrium, that's T final. So we're looking for the T final being the same for both. So minus the T final, it goes in, minus the initial, which is 10.3 degrees C. Now, for the water, don't forget the zero. We have 7.55 grams of water times specific heat of water, which is 4.18 joules per gram per degree C, times, again, T final's the same, minus my initial, which is 52.3 degrees C. Now we've entered basic algebra. So what we're going to do is our math. So when we do our math, we get 0.3648 joules per degree C times TF minus 10.3 degrees C is equal to minus 31.559 joules per degree C times TF minus 52.3 degrees C. But you can either distribute, or I'm going to simplify first, which is to divide both sides by the one side, which is the 0.6348 joules per degree C. That means my joules per degree C will cancel. This whole term cancels, so I'm left with TF, minus 10.3 degrees C is equal to minus 86.5104167 times TF minus 52.3 degrees C. So I'm going to now distribute. So TF minus 10.3 degrees C is going to be equal to minus 86.5104167 TF minus 8 minus 4524.49479 degrees C. Now, a minus on a minus becomes a plus. So what I want to do is move all my TFs to one side. So what I'm going to do is move this one over here and this one over here, which gives me 87.51 04167 TFs is equal to 4534.79479, and then divide both sides by 87.510416, 87.510416.7. Whoops, there's a 7 there. So my T final becomes equal to 51.820057 degrees C. Now, I was told to report the final temperature two places after the decimal, so T final is 51.82 degrees C. Now, as a double check, if I take T final, I can check it by plugging it back in to this equation. If I do that, then my Q of the lead should equal to minus Q of the water. I did that, double checked it, and this works. You're not going to get an exact number because of the number of significant digits, but this will tell you whether you are comparable